So what we'll do, like that, we'll build an own application for field size analysis right now. Fine. See, this is the Pylinac model, okay, which contains like most of the QA analysis for log analysis, nuclear, picket fence, planar imaging, everything is there, even for field analysis as also. Okay. So now we are building an application. Simply do the one particular QA is like field analysis. We'll do it right now. So for that, what we have to do is that we have to give the instruction here to the like how to create like how the GUI interface will be. Okay, there are two ways we can give an instruction. One is the blind, like it's a layman view. Simply type in like the we need to create a GUI. Simply we type it that it will create, but it will take a longer time. And we have a clear cut informations. Okay, for example here, see, I hope it is very clear to you. Okay. This Python, so we have to mention which is somewhat very clearly. See, in the Pylinac file, this particular field profile analysis and field analysis.py and the PDF.file. These are the three files. The most important thing to analyze the EPID based DICOM files for the field analysis. Okay. So we'll have to make sure that it is mentioned here. Okay, that is what I have mentioned here, like field analysis dot py and field profile analysis py, and the PDF is for the final results will be generated in the PDF format. Okay, these are the Python files. It's already here in this one. We are using this file to on top of that Pylinac, this particular model, QA model, we are creating a application. Okay. For that, one way to write, simply writing is that we have the GUI must have a DICOM viewer, analysis results, and the profile windows will be arranged neatly. Those are the instructions we are giving to that. This is the one simplest way. Okay. Or otherwise, we'll have to give a very clear cut instructions. Okay. So the diagnostic viewport, like it will be in the top left corner. Okay, we'll have to use the DICOM canvas powered by PyQt graph is the one of the Python library using the for analyze plotting a graph from the DICOM image. Okay, the same way we'll have to mention everything. We need an interactive crosswire for the DICOM images in the DICOM images viewer. So each and everything you will have to mention it. Okay, if you mention that way, in one shot, you will get an application as we desired. Otherwise, what will happen if you go follow this particular instruction? Still, we will going to get it, but it will have some setbacks. Again, we have to correct it. Okay, that will require like it will takes much more than 1 to 2 hours. It will take it. Okay. So I'm just simply copying it here. Okay, that particular one. I'm just pasting it here. Okay, I'm asking this particular AI agent to build a GUI application. Fine. Now that this particular AI agent based on Gemini. The same way, there are so many AI agents are available. Each performs certain task in a better way. The Cloud AI is like it's mostly known for a large scale coding. Okay, now it will check, actually it will check each and every file in this particular project. It will look for the this particular two file, and it will do the result, like it will do the QGA process. It will take a while. If you have any questions, please ask.
Hello, sir. Am I audible?
Yes, that's audible. Yes, please.
Yes, sir. I had one doubt, sir. With this trajectory file, sir, we
Mm-hmm.
can find out the parallelism of jaws, sir. You know that
Uh,
angulations we will measure it out, no, sir. That one.
No, uh, for no. When this with this one we cannot able to find the parallelism of the jaws, but there are other ways to find a same. Not with the Pylinac model. There is another code is there.
Okay,
From
okay.
there we can able to find a parallelism of the jaws. It will give you the all the four jaws parallelized parameter with certain angle values also.
Uh, Okay, that is
Uh,
image based, sir, or internally
no,
this
no, that is
trajectory file
image
it will
based.
give,
That's
sir.
purely image based. We have
Okay,
to
okay.
give any field size. Mostly the larger field size, 30 by 30 or 40 by 40 field size. If you not 30 by 30, so not 40 by 40.
Okay,
If you give a 30 to 35 exact square field,
okay, sir.
there
Okay.
is a logic behind it. It will analyze it. It will give you the each jaw's parallelism value, whether it is deviated from zero point 0.1 degree or 2 degree. So usually zero point 0.1, 0.2 degree. It will give you the clear cut value.
Okay, sir. Okay, I think manually we adjust the angle, right, sir? In case any
No,
error
if
comes,
in case
engineer
if it is
will.
there, we can manually adjust it.
Okay, sir. Okay, thank you.
Okay, then I'll share you the code once if you want.
Yes, sir. Definitely. Thank you.
Yeah.
Hello, sir.
See, yes, yes,
Uh,
please.
sir, like Python, we want to install this anti-gravity program, sir, for creating any application.
Yes, this just like a PyCharm, we have to install it, but it's lost a lot easier than the PyCharm. The installation process and everything. Okay. For
Sir,
that
in
we
any session, will you include how to install it
how to
for
install the PyCharm,
beginners? It
right?
will not Python,
Uh,
sir. This anti-gravity
and
is a totally different program, sir.
no, it is an IDE along with the agent. Okay. See, simply search here in a Google anti-gravity. The first result will come like Google anti-gravity, something like this. Okay. Can you able to see the window, my window, right?
Yes, sir. Yes, sir.
Yeah. If you click it anti-gravity here, in this corner, top right corner, there is a download options will be here. Once if you click it, there will be three options for which system you are, which desktop you are downloading it, whether it's a Mac OS, Windows, or Linux. Then in that one, there is a download for 64-bit one. If you click that, sorry, if you click that, the application executable file will open. Okay, you'll have to save it. Okay, it is already there. I'll do it somewhere else. Okay, okay, it's downloading here right now. Okay, can you see the antigravity.exe?
Yes, sir.
Okay, it will take a time. In the meantime, see, it has created implementation plan. Okay, if you read it very thoroughly, it will give you the picture. Main application structure will be like this. The based on which Python library it is using for a user interface, and the how the section is like a divided control sidebar image viewer. One is the analysis plan. Okay, and the file management, load icon button, the image controls for window width and window level, everything is will be mentioned here. Even it is we have mentioned like we have a drop down for uh, variant electra protocols, drop down for protocols. Okay, once it is done here, we have to give a proceed. Okay, if we given a proceed, now it moving on to generating a GUI based codes here. Okay. See, I don't know who's that. Anu, right? See, anti-gravity is
Yes,
installed.
sir.
Okay. Once the anti-gravity is installed, you have to simply click it here. Okay. Now the anti-gravity is currently running. That is not opening. I'm simply canceling it right now. Another window will pop up. Okay. There are some check boxes are there. You have to check everything, and you have to press next button. Within a second, within a few seconds, couple of seconds, it will be installed. and this is the icon file. Will be somewhere something look like will be look like this only.
So when we open this one, sir, we will get all these Python files which we are seeing on left side of the screen, sir.
No, this particular section is called project. Okay. Now I cannot able to go through this right now because this it was generating right here. We'll have to create your own project here. Okay, you have to create a new what do you call this? Open the folder or open the file or new files. Like you have to create a new project depend upon your need. See here I have already opened by clicking the open folder. I just opened the folder where Pylinac models are stored. Okay, so in that particular explorer, I see these all the Pylinac models are already stored in this particular location. So I opened it. I simply mentioned these two files are mandatory to me. With these files, just create an GUI. So now it is doing the job.
So we need
If
some Pylinac models to use this, sir.
yeah, see, first you have to make sure that what you need exactly and what kind of a problem you have, what kind of a challenges you have. Based on that only we have to work. Okay. Now we have choose that we need to do a field analysis. Okay. For that field analysis, hold on a second. For that field analysis, every time we have to give a run command if any error comes like that. We have to, yeah. For that field analysis, we have chosen that Pylinac model to do it. Okay, it is already pre-built field analysis QA is there. I have chosen because it will be it will be faster to do it. Otherwise, if we without this Pylinac model, still we can analyze the EPID based DICOM based images field analysis, but it will take uh, lots of resources to go through. It will take a lot of time to generate the code and what do you say, debugging the code and validating it. So it will take a lot of time. So this is already there. By using that, I'm just creating it. It's a much easier and simplest way. So we have to decide
Okay,
first
sir.
what is the problem you have, like what is the task you want to carry out. Based on that, we'll have to work on. See, if you see like this, we have given an implementation plan. See how to implement it. Okay. Now it will automatically think. Okay. Automatically think, and even it will execute that data in the back end. And if the error comes, it automatically goes back and correct those errors. And finally, it will give us a full-fledged GUI. I'm doing it for the first time, this but for the particular field analysis, right? Even for the job parallelism, which Mr. Nandakumar was asking, we can able to do the GUI for that also, which we already have the code. See now you can see the field analysis.gui.py. That code is completely generated here. This the whole, I don't know how much lines of code is there. Nearly 330 lines of code is generated right now for the GUI. Okay, and still it's running. We'll have to wait for a few more minutes. Just keep on running and correcting the error. Then only we can able to proceed with the GUI. Right now, I just run this program like field analysis.gui is there. I just by using this run this particular Python file. See the error comes at like model not found. Okay, model not found. That is called numpy. Okay, so the particular Python library is not there. For that pip, we have to install that particular file. Pip install numpi. So now we are installing that. Particular model here. So now it is showing that we have to upgrade certain things also. That pip installation file is also missing. So I'm just upgrading that. Okay. So still there are some errors are still popping up. Okay. What we can do is that simply copy it, say fix the issue. Okay. And just simply copy this error and saying giving the instruction to this AI agent to fix the issue. Now it will do the work. See, simply downloading this out, like, okay, I made a mistake here. In this particular pip install not by is not supposed to be the typing error was there. That is the reason it's not installed. The pack after the package is installed, based on the input we have given, the GUI application has been generated here. Now this particular tab is to load the DICOM file. Now we'll try and executing how this particular application is working. Okay. See, once it is loaded, the DICOM viewer shows the 10 by 15 file. So this is we used for window analysis, and this is for the window with something. And it has given a protocol for variant CMS Electra, and for the which beam centering, whether you require beam centering or geometric centering. It is having a which edge detection method you want to go, like full width off maximum or inflection here. And the normalization will be beam center. Okay, let's see how it is analyzing it. Once it is analyzed, I hope you can see the results will be shown here. And these are the in plane and the cross plane images. Okay, the same way which protocol is used. The one thing I have missed out is that to generate a report. Okay, so there is no button or toggle not generated for this for generating the report. I think I'd say, okay, let's use this save figure. Okay, it is to only to save the figure, not to generate it. Okay, the same way we can, in the same way we can able to generate like any kind of a GA for your repetitive tasks. Let's check one more thing for 20 by 10. Okay, this is the 20 by 10. They're using the same way. We are analyzing it. Okay, this is the in plane horizontal profile. Okay, it is it now as per this it is completely wrong. It's like this is like in plane. Okay, that's perfect. This is supposed to be in plane. Okay, not this one. And cross plane is like this one. Uh, okay. Now this is the logic behind it. Then we need to correct it. We have to mention that not this particular is the cross plane and this one is the in plane. Okay. This is the part. This is our as a medical physicist responsibility to validate the code. Okay. So we have to be very clear on that. Clear on which part. So building an application nowadays it's very easy, but our responsibility lies in that to reviewing this particular code and we'll make sure. See, here we found out that in plane and cross plane are swap. Okay, now we have to find and which part of the block of the code giving that defining that in plane and cross plane, and we have to correct it. That is the main thing here. That's the purpose of the whole coding part. The coding has been changed in this after the AE agent is evolved. Okay. Is there any question or we'll wind up this session right now? Mr. Soundarajan, do I need a subscription for? No, no, no. Actually, this is kind of a free. This is based on a tokens. Nearly 10,000 tokens they are giving. Okay. practically free. Actually, we can use it for a small scale projects. We can use it. There are so many ways we can get as a free. If you are using it, Geo services here in India, like for 18 months they are giving free. Literally 18 months complete, we can use the Gemini Pro. Okay. Like literally for a small project, if you are having a several Gmail account, still and by using different Gmail accounts, still we can opt for a free one. Okay. And do we need a different log parameter? Yes, we can analyze film images for field analysis in Python. Yes, exactly. But still, that film analysis, we have convert the film to DICOM image. Okay, there is a separate code is there how to like, convert the film to DICOM images. Then we can still analyze that film images. But we have to make sure there is no sharp points or bends, and it has to be the film has to be perfectly scanned. If you have any questions, drop it here, or you can unmute your mic. We can ask. I'll share you the code for parallelism, job parallelism to Nandakumar and tomorrow by in the. Is there any questions? Just like anti-gravity, there are so many other tools also available. AI agents are available. I find like this one will be much easier and free to use comparing with other AI agents. Any questions, or will wait for 5 more minutes? If you have any questions, then we can ask. Okay, then we'll wind up the session. And thank you for your time. Still learning.